Start the recording. We'll fade the music. Stop that. Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the DB2Night show. And today we have a return special guest, Greg Stager of the IBM Toronto Lab, talking about DB2 security. One of the things that Greg and I and many other people learned in Edinburgh is that you can travel and you can still get COVID. And so it's caused a slight hiccup in our schedule. It's not anything that can't be resolved early in the new year, where we'll have Kerry Romanoff back to talk about DB2 11.5.8. But it does mean that Greg was very happy to step in and help us out again with the DB2 security primer. And with that in mind, Greg, how are you doing today?
I'm doing very well, thank you, Martin.
Good. It's great that you're back. And but
I'm glad to be here.
I've run into a number of people. My dear wife and I were talking about doing some vacations, and we're going to wait probably till the middle of next year at the earliest. But that's just us because we're cautious people, and frankly, we've had COVID once this last year, and that was plenty for us.
I understand.
Yes, I'm sure you do. Now, looking at just the social media we have for the show, we have announcements on Twitter. Hopefully that'll continue to work. I'm not sure we have a blue check mark, but people know what DB2Night is, and people have been finding us and signing into the show. And our replays are now on YouTube, and that YouTube channel is getting more and more traffic because it's a real easy way to look at shows without having to wait for downloads. There's our disclaimer and trademarks and all that type of stuff. We used to read this, but life is too short. So we'll just let you see it there. We respect all the trademarks. We're careful on that. We're recording things and stuff like that. So there we go. Thank you, the lawyers. Today's shows, as always, we have the quick announcements on upcoming shows, audience polls, and there we go. Okay, I've got some really good leads on things coming up. Those are the dates we have for upcoming shows. January 20th and February 10th, I'll have at least one user presentation, and we'll get into our featured IBM presenters throughout 2023. Next week, in preparation for Christmas, we have a presentation from Brian LUW of Manulife. That's a user presentation on temporary tables in DB2. Including global declared versus created, and how to use them effectively, and other things that Brian learned on that. And that's a great tutorial, and I think you'll enjoy that a lot if you're able to attend. And again, I've got some things going on. I'll certainly have by the end of next week, for next week's show, I'll have the TBAs filled out, or certainly for January. I seem to be getting lax in my old age, but the old thing with a webinar is we don't necessarily need to fill out the whole schedule at once, because people are generally home these days and they don't mind presenting on the DB2Night show. As always, always has been, the founding sponsor of the DB2Night show is DBI Software, and we encourage you, if you're interested in DB2 LUW performance, to look at their website and watch a demo and that sort of thing of their products. Continue to have success. The company's been around for a good 10 years now, or longer actually, and it's worth looking at that information. Our winner from last month is Dan Luxtitich of Dan L Consulting. He's a gift certificate winner, and congratulations, Dan. And again, our sponsors are DBI and yours truly, Martin Hubel Consulting. Now we're into our polls. Get the polls. These are fresh off the press here. Our first one, the standard thing we normally ask people is what versions of DB2 are you currently running? And can select all the ones that apply to you there. Let people vote. We'll close that and share the result. Kind of a 50-50 day. Some people are really current and some things are getting a little old. Next question. This is one I just came to me because I continue to hear this on our news up here. The thing with some security breaches is for publicity reasons, people don't tell us, but it seems every time we look around, we see more and more people reporting security breaches. And I won't necessarily make people hang in there, but we'll close that and share that result. Well, this week, yeah, that's the same.
Yes.
We had a school board near just outside of Toronto, still recovering from a security breach they had last week. So security might not be something you want to talk about, but you better think about it from time to time, as the old thing goes. When was the last time your company or you held a DB2 audit in your company? And just in terms of, and a lot of people might not know on that, but that's okay. Hopefully management gets around and thinks about that from time to time. And so we'll close that off. And the last question we have for today is, what security features in DB2 do you use? And this is an interesting one. They've got, starting in 11.1, there's native DB2 encryption of databases, so data at rest can automatically be done. It takes very little work to really set that up. I know I've got friends that whenever they create new databases in their company, they basically always encrypt them when they set them up. So that's interesting to look. And what we're seeing right now from our good-looking studio audience is that we have people using the first four. Row and column access control is not being used, but I know from other companies that that's fairly popular as well. Okay.
Well, maybe we can help solve that today.
Yeah, the other one, though, is label-based access control, where basically that's a heck of a lot of work to set up, and I don't know anybody using it because the defense contractors that might need that aren't going to tell me about it. So that's just the nature of what goes on. Okay, with that, the next thing I have is just a little cartoon I found on the internet. Last month I was putting up cartoons of snow because we had quite a bit in Toronto, and then the temperature went up above freezing. And so now we're back to looking at green grass and leaves that still need to be raked up. And maybe next week, or everybody always wants to have snow in time for Christmas. Otherwise, the ski areas north of Toronto don't get as much business over the Christmas holidays. So we'll have to see what happens there. And with that, we're ready, Greg, to turn things over to you. And let me just find the attendees here, and we'll make you the presenter.
Great.
And here we go. We know this works, and I see your screen.
Perfect. Okay, thanks, Martin. I'll get started. So thanks, everybody, for joining and tuning in. My name is Greg Stager. I'm with IBM Canada in the DB2 development organization. I've been here for coming up soon on 23 years, working in DB2 development, most of that time within security. So today we're going to talk about a security primer. We're going to have an overview of all of the security features that DB2 provides, so that to make sure you're aware of them and getting the most use out of them. So it's going to be a pretty quick whirlwind tour today. So I just want to do a quick plug, though, before we get started, for the Center for Internet Security, CIS. This is a community-driven nonprofit organization. They do a few different things, but one of them is they publish what they call benchmarks. This is for all sorts of products, operating systems, all of the database servers, web servers, that sort of thing. which are a series of recommendations for security hardening and installation. So they're just basically, list after list of, we recommend you do this, we recommend you set this configuration parameter for a secure environment. And I've recently been working with CIS to have the DB2 11.1 and 11.5 benchmark published. And you can find that at the URL listed here. So it's a great resource that's been recently really updated for DB2 11. So I just wanted to make everybody aware of that. So if we look at the overall security landscape and the features that DB2 provides, it's really broken down into 4 main categories: authentication, authorization, or sometimes called access control. Yes.
We're seeing your PowerPoint thing, not the actual presentation. I wonder if you could flip where your presentation is. I can see you're in presentation mode, but we're only seeing your first screen there. And
it didn't update to the next screen?
No.
It would just stayed on the main.
You're not in slideshow mode right now, or what we're seeing.
Well, I was. Did you see this page? Did it switch now?
No. Is it showing on a different monitor? Is there any way you can go into your slideshow?
I only have my laptop monitor. I don't have an external monitor plugged in.
Go into the slideshow monitor though, and see, or slideshow where it says slideshow.
Yes, and we'll do. I forget which one of these is the right one. Better or not the same?
No, you're still on the. Go into custom show. Let's see what's in there.
Sorry, I'm just gonna try one thing.
Yeah.
Does that one help?
It's white.
It's white. Okay, I'm gonna change. Just show my whole screen instead.
Okay.
Let's see if that, instead of just PowerPoint.
Either that or there's a second setting you have on your PowerPoint where it shows PowerPoint presentation. Just check that.
On this custom show?
Let's have a look in there. Click that. We'll see.
No, I think it's you can set up slides, individual slides.
Fair enough. How about presenter view? Up beside the custom show, there's something called presenter view. There.
Yeah, that's what I. Oh, this is the. It shows me the presenter view, like.
Right.
Yeah. That's not what we want. So I'm going to stop showing because I need to change. Oh, I can do this. My main screen.
Yep.
And then.
There. Does
that look better now?
Yep, it does.
Okay.
Thank you.
Okay. I'm sorry about that.
No worries. No,
I didn't realize it wasn't showing it.
Hearing your voice, but I realized you wanted to show us a little more.
Yeah, okay, I do. It would be a bit boring if it was just my voice with no graphics here. So, yeah.
Super.
Here we go. Okay, so I'll get back to it. These are the 4 main areas of security that we have. So there's authentication, authorization, or sometimes called access control, auditing, and encryption. And then we will continue on here. So we're going to go through each of those. So authentication, what is it? So it's really proving who you say you are. You come into the database with some set of credentials, whether that's a user ID or a password to say, this is Greg versus Martin, and we need to know who you are. So we're going to check those credentials. DB2 doesn't directly do it itself. We rely on external third parties to do that validation. Typically, it's the operating system, not always, as we'll see in a minute, but we're asking something else to do that validation for us. There's a parameter called authentication, which controls which type of mechanism that we're going to use. There's some other controls on top of that. But for the primer here, we're just going to talk about sort of the basic level of what's available. Once we have validated your password, checked with the operating system that it's good, we know who you are, we're going to map that to what we call an authorization ID, which we'll talk more about, several slides on what that means. And then we're going to get your groups. And group membership is also defined outside of DB2. So we talked about the operating system being sort of our default place where we look to validate a user ID and password and get your groups, but there are a few other options. There's Kerberos. This is a technology invented by MIT. It's actually used for Windows authentication under the covers. You don't really get to see it, but it's what Microsoft uses there. It's a single sign-on solution. So once you get your Kerberos credentials at the client, you can actually connect then to DB2 without a user ID and a password. So it's popular for that aspect. The only thing is there's no group memberships through Kerberos itself, so we'll still look to something like the operating system or LDAP for a user's groups. We do support LDAP. A couple different mechanisms to do that. One is sort of an LDAP plugin where DB2 will actually talk directly to an LDAP server to gather all of the information. We support customized plugins where a customer can actually write their own security validation of credentials. So we have two different types. One is a user ID password plugin, and another is a GSS API based plugin that stands for generic security services, and it's an industry standard set of APIs for doing authentication. And we support a group plugin as well. So it's not for the faint of heart. It's quite an advanced topic, but it's available for customers who sort of the default choices don't quite meet their security needs. But out of all of those, the most popular one we see customers using is what we call transparent LDAP. And this is the use of the reason why we call it this is the use of LDAP is actually transparent to DB2. DB2 is still going to go to the operating system, but we are going to call certain set of APIs at the operating system that allow it to look either locally or to LDAP. And that's all configured within the operating system. So you just sort of tell DB2, hey, call these other set of APIs, and it's a registry variable we see here at the bottom called OSAuthDB. You set DB2 auth registry variable to that, and we'll use those other APIs, and now the operating system can go where it's configured. So typically you can have some users local and some users in the LDAP server. And this is, I can't put a number on it, but I'd guess maybe 50% of customers running in this mode. Certainly the most popular mode we have for authentication. So I really strongly recommend people sort of look at it when they're setting up a system. Something new in terms of an authentication option in 11.5.4 is JSON Web Tokens. This is sort of I call it a back-end single sign-on. What it allows you to do is log into a web browser through an identity provider or an IDP, where your web application then can work with the browser and work with the IDP to obtain a JWT, a JWT or JSON Web Token that can then be used to pass into DB2 for authentication. So there's an example here on the next page, and I'll kind of flip back and forth between these two of what a sample JWT looks like. It is digitally signed. We don't show the signature here just for space, but it comes with these claims, basically saying who the user is, who issued this token, and an expiry time. And there can be additional claims in there, but these are the main ones that DB2 looks for. And the server will validate the digital signature, know that it comes from someone trusted, specifically the IDP. DB2 will have been set up to trust the IDP, and then extract out a user ID from this token. when you actually connect with it, it gets encoded with base 64, so it looks a little different than what we're showing here. But yeah, your application just connects with it. And the target really is right now for web applications, that the JOT is typically available within that application environment. So it's something, very brand new that we've just introduced. Hoping that in the future it's going to be something we can build on to provide more advanced authentication options. But even as it is, there's a use case here that it allows that single sign-on without a password with just this short-lived token. So another new feature that if you're not keeping up to date with every new feature in DB2 that we have introduced for authentication is a cache to help with performance. So this was in 11.5.3. We put in this cache to help with scenarios where you typically have a smaller set of users that are connecting quite regularly and you're having performance problems. The one customer we had, it was maybe hundreds of connections every minute, and it was kind of overloading their LDAP server. And so DB2 can cache the password. It's not actually the password itself, it's a hash of the password. So, we're not saving the actual password itself. And we can validate that. And it just saves on that constant network trip to the LDAP server. It doesn't have to be the LDAP server. This will work with any of our authentication methods we mentioned. So even if you're going to the OS, there is a not as great of a performance benefit, but certainly it's still useful. So you can configure basically two options. One is how many users you want us to cache within the database, and the other is how long you want that cached value to be used for. So the default is 3 minutes, meaning after 3 minutes, when that user comes back in with their user ID and password, we're going to re-authenticate them again. You could change it a bit longer if you wanted, right? There's always that security trade-off between performance and how much security you want. So if that user was ever, user was fired or something and you had to delete their account, how long before the cache picks up that they can't authenticate anymore? Although we actually do have a method of flushing the cache command so that you could do it instantly if you wanted. So there's just a very brief kind of picture here of what that looks like. Without the cache, when you connect with your password, DB2 has to go to the operating system or LDAP to validate it, then go back to get your groups. And with the cache, we can avoid that. We can keep the checks within DB2 as much as possible, only occasionally as necessary going out to the operating system. So especially if you're using a remote LDAP server, maybe it's not co-located in the same data center as your DB2 server, it can really help performance in those cases. One or a couple of gotchas just to watch out for. The cache is at the database level and requires that the agents be pooled, existing and pooled on that database before it can make use of the cache. So if you don't have any idle agents that are associated with the database and DB2 has to spin up a new agent to handle the incoming connection, that connection won't make use of the cache. So, in general, having pooled agents is just a good performance measure that you can look at. So specifically, num pooled agents greater than 0. If you call monget database, that will tell you how many pooled agents you have. And if it's 0, then the next connections, it won't cache it. So that's just something to watch out for. There's also an APAR that you'll want to get if you're using SSL, that we had a bug that was fixed in 11.5.7 or later, that basically when SSL was used, we weren't getting to the authentication cache, specifically because those agents using SSL were not getting pooled properly. So going back to what I was just saying, that you need those pooled agents, there was a problem with SSL that we were always spinning up a new agent. And so that agent was never associated with the database and was never making use of the cache. So if you are using SSL, you definitely want to make sure you have that APAR. Okay, so that's the brief look at what we provide for authentication. And so we'll step into authorization then. So we talked about proving who you are. Authorization is all about what can you do. There's authorities and privileges. You'll hear those terms in the DB2 documentation, and they are permissions of what you can do within DB2. So permission is sort of a generic term. It's letting you do something. And we divide those into two. So what we call as an authority is a predefined collection of permissions sort of within a specific domain or a related area. So it's kind of like a high level, that this is the database administrator type of concept you're looking at here, where it's not just one thing you can do, but it's a related set of permissions that you have all related to administering the database. And that just gets juxtaposed with a privilege, which is a very, very specific thing. So it is a small permission on a specific database object. So this is, for example, select on a specific table. So it's not the ability to select from all tables, which is an authority that we call data access, but rather it is one specific table. It's got a name, T1 or whatever your table name is, and it's just the select privilege. So you group together all of your privileges, all your authorities, and that's sort of the entirety of what a user is authorized to do within the database. We provide a number of different authorities. These are sort of the main ones. There are a few others at the database level that we don't really get into in the primer here. But at the instance level, there's mainly the sysadmin, who sort of controls everything for the instance, and then some subsets of that are kind of a smaller subset of what the previous level can do. So sysadmin can do everything at the instance level. Syscontrol can do a subset of that. Sysmaintenance can do a subset of that. At the database level, similarly, you have your database administrator, who can do all of the actions kind of related to creating objects and administering the database. A subset of that is SQLadmin, who is responsible for monitoring and administering the use of SQL statements. So can't go creating objects, that sort of thing. It's just more about monitoring the health of the database. There's a security administrator whose sole job is administering the security of the system, can create audit policies, can do all the grants and revokes, can create, we'll get into some of the more advanced audit objects that a SecAdmin can control soon. There's a subset called access control, which is just about the grants and the revokes of your basic privileges. So this is sort of, you can delegate off to a user the ability to take care of who has access to basic tables and routines and objects like that, but can't necessarily control some of the more advanced security features. And then there's one authority called data access. Watch out for this one. This is a very powerful authority because it lets you access essentially any table in the database and run any routine in the database, have execute on any routine, or most of them. So it's very powerful in that you can essentially see and do everything in the database. Typically, from a security best practice, nobody would have this, and you would be granting on a need-to-know basis individual permissions, or sorry, individual privileges on the objects that you have. New in 11.5.5 is schema level authorities. So this is pushing down some of those database authorities into a schema level so that you can only administer within that schema. So, for example, data access will let you see any table, access any table, execute any routine, but only within that schema. So this allows you to, maybe you have a specific application isolated to a specific schema and granting that level of control. One thing to watch out for historical reasons, when you grant DB2, you also get data access and access control by default if you don't specify anything else on the command line. So just as a refresher, when you have, I'm going to draw out the pen here. When you have this line, everything above the line is the default, everything below the line is an option you can specify. So if you just say grant DB2 and nothing else, follow that line straight across, it will by default have with data access and with access control. And just data access being that really high level that lets you get access to everything, be cautious of that. It would be a lot better to say without data access and without access control, and then explicitly grant data access if it was required. So just because it's that default sort of hidden away, I just want everybody to watch out for it. Along with the new schema level authorities, we introduced a bunch of privileges at the schema level as well to help with access to the schema. And they're all very similar. I'm going to go through select in as an example, but you can see how that applies to insert, update, delete, and execute. And select in is letting you select from any table in the schema that exists now and in the future. So this doesn't just go and grant you select on any table that exists. It's a separate privilege that's maintained explicitly as a select in privilege that says at the time of your execution, you can get at any table. So if that table doesn't get created until the future and you go to select from it, you'll still be able to select because of this select in privilege. So that can really help, again, management at that schema level if it's appropriate for a user to have access to all tables. It's just a single privilege. So who can hold these privileges? We mentioned when you first connected, we validated your user ID and password, that we will determine on authorization ID. So this is a term that you'll hear and see throughout the DB2 documentation. It's not just a user ID. So an authorization ID is a name, a value, and a type. And it can be a user, a group, a role, or the special one, public, just meaning everybody. So you can have a group. Once we determine what your groups are, they become internally to DB2 an authorization ID. So when you hear that term, it's not just the user, but it can apply to these other types as well. We will, though, say the primary authorization ID. That's really the user that connected. And for that user, we will have secondary authorization IDs. And those are the groups or roles that are then associated with that user, okay? And then are used for various authorization checks. There's places, we will consider what privileges have been granted to your roles and your groups, as well as to the user themselves. There's another set not another set, but another type of terminology associated with authorization ID that it just helps to be aware of, which is system, session, and statement authorization IDs. Normally, when you just connect to the database and issue a dynamic SQL, they're all going to be the same, but they can be different. The system and session authorization IDs are generally the same and generally the user that you connected with. The session, there's certain statements that can actually change your session authorization ID. It's a bit of an advanced topic, but this is usually the user that you connected with. The statement, though, which is the authorization ID DB2 checks when it sees if you can run a particular SQL, can change and may change frequently. It starts off as your user ID, but there's certain contexts in which it will switch to be a different value. And we're going to go through some of those in detail now to see what they are. Well, I guess after this slide, we're going to go through them, these temporary places where you can get different privileges. So how do you get them? Sort of three different ways: explicitly, implicitly, or temporarily. So what we call explicit mechanism is someone has granted your user group or role a specific authority or privilege. So you're able to select from this table because someone has explicitly granted you select on that table. Implicit is when DB2 does the grant sort of on your behalf, typically when you create an object. So when you create a table, you're going to be granted certain privileges on that table. So the SecAtom didn't come and explicitly do it, DB2 implicitly did it when you created that object. And the third type is temporarily through a number of sort of different execution contexts. So when you're looking at a view, static SQL, or trusted context, there's ways of you temporarily getting access to different privileges. Okay, the temporary access. This is probably, the others, the explicit, implicit, are pretty obvious. Temporary access, though, does require some more explanation. So inheritance, this is the most often used that you'll run into. For example, a view represents sort of a security boundary in that the user who created the view needs to have the privileges on the underlying object, but the user of the view, the person selecting from the view, does not need to have any privileges on the underlying objects. So if that view is, say, selecting from a table, the user only needs select on the view now. They don't need select on the underlying table. And that's because that view is a boundary. The view creator needs to have those privileges, but then they can give out access to the view, and in that mechanism, control how other people see the underlying table. Maybe they don't want them to see certain columns, or they want to see, access these tables only when they're joined together in a certain way or something like that. So that's sort of a temporary access. You can only access that underlying table when you're selecting through the view. Similarly, execute privilege on packages that have static SQL behave in the same way. That package is a boundary that transitions from the user calling the package to the package binder who created the package, what privileges they have. So for example, that package may delete from a table. The package binder, the package creator has that delete privilege, but nobody else does. But they can now just give out execute on that package, and it would allow other people to delete from the table, but only under the control of that package. So maybe there's, it's letting you delete only certain rows, for example. So again, you temporarily get the ability to delete from the table, but only under the control of the package. One other way of, in a similar manner, getting a temporary access to a privilege is dynamic rules for dynamic SQL that's in a package or a SQL routine. You can control who that dynamic SQL runs at. Is it run as what is by default the caller, or can you actually change it to be the routine definer, so it can run under the temporarily under the privileges of the routine definer? And trusted context. So we're going to get into more details on trusted context in just 1 second. But again, it temporarily allows you to get other privileges you haven't, you by default don't have. So what is a trusted context? It is a relationship and a rule that's created within the database that says when a specific user connects from a specific IP address, I'm going to grant them additional abilities within the database. They are sort of meeting this level of trust. And it's typically there for web applications. And we're going to see a picture of that in a minute. There's two types. There's an implicit trusted connection and an explicit. The only difference is implicit means you didn't ask for it. DB2 just says, oh, hey, I recognize your user ID from this IP address, and maybe you're using encryption that we specified. Oh, that's implicit. Explicit is when you actually ask and say, hey, I really want this connection to be trusted. In both of these cases, you can be given access to a role that is not normally available to you outside of that trusted connection. And that role can then give you additional privileges on certain objects. What this is saying is, oh, only when it's your user from this specific machine with this IP address, and typically a web server or web application, are you going to get these additional privileges. So if you're just connecting from your laptop, you're not going to be able to do whatever it is that that role controls, and you're only allowed through the web application. This is just a quick example of an implicit trusted context. There is a create trusted context statement here saying who the user is, in this case Miller, with this IP address, and they are going to, in this case, get a connection role. That role has connect on the database, which has been revoked from public. So by default, public cannot connect. If this user, Miller in this case, connects from the IP address which matches, okay, what was over here, they can connect because we're going to match this trusted context. DB2 says, yep, okay, it's Miller from this IP address. Oh, when they connect, they get this extra role, and that role gave them connect privilege. This is just an example where they're getting connect. It could be access to sensitive tables, select on tables, or whatever privileges you want to grant that role. If they're coming in from some other IP address, they're not even able to connect in this example. So that was implicit. Explicit is a step beyond that, and it allows the web application to actually switch to other users, potentially without any credentials. That's sort of optional. So the idea being that a user's connecting into the web application, they've authenticated there. This allows the web application now to switch amongst users very quickly. And it's probably best represented as some graphic here. So this is before trusted context, this picture. We have many users connecting. They each have their own privileges that they require. When the web application here in the middle connects to the database, it needs.
Greg, your sound just cut out.
Hello, can you hear me now?
I can't.
Okay, great. Sorry, I think my headset just turned off. Sorry about that. I'll continue on then. So what we have here is the application server needs the sum of all of those privileges. Right? It's going to need everything, access to everything in the database, which is, a potential security risk. Okay. What trusted context does is we still have those same users connecting, but the middle tier, the web application is going to use a trusted context to connect with. And we have the sample, just the create statement down here. It's going to connect first as its app server trusted ID, and that's what matches the trusted context. But after that, it is now going to do a switch to each of these users. It's going to switch to user 1, switch to user 2, and so on. And each time it's switching, really that the two things happen. One, the end database, the DB2 here knows it's user one connecting now, and which privileges, only the privileges user one needs have been granted to it. And so two things happen. One, DB2 knows who the user is, and that connection now only requires those limited set of permissions. You switch to user one, and user one has only been granted select on one table. The application server now switches to user two, and that connection is running as user two, which only has privileges on a different table. You don't have that sum of privileges anymore. So it's really pushing down or asserting the user's identity into DB2 and only requiring individual sets of privileges. So that's, an explicit trusted context and the benefit that it brings. DB2 has a couple of other advanced access control features that are called fine-grained access control features that let you sort of tailor things down to the row and column level that are good to know about. There's two of them, label-based access control and row and column access control. These are both a type of mandatory access control such that it requires a security administrator to set up and define these rules. So it doesn't matter whether a table owner has granted select to public, these rules will still be enforced. So yes, public can select from the table, but these rules can limit what access they actually have. It's sort of like a layer on top of that. So label-based access control, this is basically a method where you label your data. Each row gets a label. You optionally can have a label for a column, and users get labels. And those labels have to match for a user to be able to see that row. And this is traditionally in your sort of military and intelligence domains where you're putting something as confidential, secret, top secret. So a user that has been given the secret label can see everything that is secret or confidential, but they won't see the rows that are labeled as top secret. Similarly, they can't, when they do an insert, if they have the secret label, they can't sort of declassify information. They can't write it as confidential. Everything that they write is considered secret and has to be labeled as secret. This is we'll say, a difficult technology to use, I think, that it requires more storage in the database for you to label everything. And really the hard part is you have to know how to label stuff in advance and really set that up before your tables get even created. So it requires a lot of forethought. That's why we developed this. LBAC came first, and we went on to develop row and column access control, which is a much simpler and flexible technology that allows customers to essentially write SQL-based rules on how to access those tables. Okay, so nothing gets labeled up front. You're going to create some rules that get applied to all of the SQL that run against those tables. And there's two types of rules. One is a row permission that is an SQL search condition that describes which rows get returned. And there's a column mask, which is a case expression that determines the value for that column that gets returned back to the user. So we have a really simple example here. We're going to go through a row permission and a mask. We're saying here we're going to create a permission with a name called row access on this particular table. And we're going to say for rows where, and this is the same where clause that goes on your select statement, if you are in the patient role and the patient ID column matches your session user. Or another case, you're a doctor and the doctor column matches your ID, then you're going to see these rows. Otherwise, you don't get to see the row at all. This is best shown with an example here. You'll see the power of this. We have a table at the very top here. This is just the base table that DB2 knows about. We have 3 different users all issuing the exact same SQL statement, select star from this table, and they are all getting different number of rows back based on the rule that we just defined, the permission. So Mr. Bogart here is a patient. He matched the patient ID. He gets to see his row. Dr. Dean is a doctor and gets to match all of the patients where Dr. Dean here is the doctor, is listed as the doctor, right? So Dr. Dean gets to see his patients. And Ms. Harlow is neither a patient nor a doctor and will see no rows from that select statement. So if we go back to it, what goes in this after this where clause here is this, I won't say it's arbitrary, you can't put anything, there's certain rules, but you can definitely reference UDFs, you can join against other tables, you can do a lot of powerful things in here to help you determine who has access to the table. And this where clause is basically just put on the end of every SQL statement that comes against this table. You know, with that power comes responsibility that this can affect performance, right? Depending on what you put in here. So if you are doing a lot of joins against other tables, right? That can add expense to your SQL statement. So watch out for that. Column masks. This is going to return different values for a column based on the rule that you create. So again, we're going to create a mask on this table specifically for this column. And it's a case. When it's a user in the payroll role, they get to see the actual SSN social security number column. If they are in development, they see a masked value, right? So we are putting in the X's and then only taking out as a substring the last four digits. But if they're neither of those, they actually get a null value. And so again, we have an example here, your base table. We have payroll, someone in the payroll selecting it, they get to see everything. If they're development, they only get to see the last 4 digits. And if they're not in either of those, they get to see nothing. So, you know, this is great. We can mask out what we see. Masking can be troublesome at times, has to be done with a lot of thought, just that you're changing the results that you get back. For example, if you want to return null, you need a nullable column, right? You need an application that can understand that, oh, I'm going to get X's here instead of potentially a numerical value, or, you know, all zeros, or whatever you mask result returns to, that they're going to get that. So, but at the same time, it really can control what users get to see. So it's, you know, a great feature. Okay, that's the end of authorization. We have a lot of features that help you control what people can see within your database. We're going to quickly go through the next two. Auditing. You know, auditing is going to let you see what people do. There's sort of 2 aspects you can think of for this. One is the built-in audit facility that DB2 has, but we also allow integration with external products. One specific example is IBM Guardium. We actually can send data that's received by the DB2 server to Guardium for them to analyze and audit. We're not going to get into that today, just to be aware that's a possibility, but we are just going to go quickly through what the internal DB2 audit facility allows you to do. It's a set of events that basically record who, what, where, sort of how, you know, any access happened. Okay, we divide them up into database and instance. There's very lightweight auditing at the instance level, and much more configuration can be done at the database level, as we'll see. We break all of those events into categories that help you sort of control what type of information you're interested in. Auditing can be a big hit on the system, so turning it on for everything can be a performance impact. So we're going to let you control exactly what you want to see audited. So we have a number of different categories here. Audit are events related to the audit facility itself. So if you create an audit policy, if you change an audit setting, those fall under the audit category. Checking is anytime DB2 sort of makes a yes, no decision about whether you can do something. That's us checking your authority or privileges, and that will be an event audited in that category. Object maintenance, categories for whenever an object is created or dropped, and very little alterations. So it just lets you track, oh, this object, as they come or go. Security maintenance are changes to security controls. So really grants and revokes fall into this category. System administration, anytime you sort of are doing a system level administration event that uses like a sysatom, fall into that category. Validate, checking your security information. Context, it's kind of a catch-all that helps you understand the context of when these other events are occurring. Was it part of an execute immediate for someone issuing SQL statement, or was it some other tool that was running or something like that? And the execute category is specifically this SQL statement was executed. We provide a granularity of what you want to audit. So those categories get combined into a policy. So you can say, well, I'm interested in the checking event and the segment event, and I create a policy with that, and then you can associate that policy or audit something within the database according to that policy. So you can audit everything within the database, a specific table, users with specific authorities, specific users and groups and roles, or anything that happens within a trusted connection. So you could say, well, I really want to know everything my DB does. So I'm going to create a policy that sort of has all these categories turned on and audit just my DB or another specific user, or anybody who has a membership in this role. Or you maybe have a specific table, so you want to do an execute category saying, show me all of the SQL that gets run against just this one table. So again, you're limiting yourself. You're not auditing just every action within the database because that can be expensive, but you are auditing just the thing that is most important to you. This is just a picture kind of how the audit facility works. I'm going to leave it as homework for everybody to kind of study that and see how all the moving pieces go within audit. That just leaves us down to encryption. So there's really two areas of encryption that you need to worry about. One is guarding communications. You'll also hear it called data in transit. Or guarding database storage. You'll hear that referred to as data at rest. So we'll talk about each of those. Data in transit. So where is this relevant? Where do you want to be worried about this? So this is network communications between the client and the server, between HADR primary and standby, between DB2 and external products or services, like encryption key managers, for example. How is it done? So the industry has standardized on a technology called TLS, Transport Layer Security. You may have heard of it as SSL, sort of the older term, Secure Sockets Layer, but it is encryption at the network layer. The current industry standard is TLS 1.2. That's sort of the widely deployed level, although 1.3 has just, in the past few years been finalized, and as we'll see, supported by DB2. 1.2 is considered secure. It's fine to use. 1.3 has sort of fixed what the industry sees as potential future problems, and sort of getting it out there now, just knowing that it's going to take, probably take a decade for most things to transition over and get there. So kind of want to get moving on that before these things become a problem. So, if you're using 1.2 right now, that's fine. It's still, very secure. So the SSL handshake is kind of interesting to quickly go through and how that encrypted communication gets set up. So the client connects to the server saying, hey, I'd like to use SSL, and here's a list of supported encryption ciphers that I'd like to use. The server responds back, agreeing to one of those encryption ciphers and including its digital certificate, which includes a public key. So the client sees that certificate and it's going to check it. It's going to validate that it hasn't expired and that it's issued, meaning signed, digitally signed by someone it trusts, right? So that it sort of knows who that server is, and that it's talking to who it thinks it's talking to, and that it's established by someone trusted. It takes that public key out of the certificate and encrypts a session key. So if you remember details about public and private keys, what you encrypt with a public key can only be decrypted by the private key, which the server has kept private, as the name suggests. So the session key that it's encrypting with the public key, it now knows that only the server can read that key. So it's going to send that value over to the server, and the server is going to decrypt it. This session key is what's called a symmetric key. It's not a public-private key. It's the same value on both client and server. The reason you do that is symmetric keys are orders of magnitude faster to encrypt and decrypt with than public-private keys. So you use the public-private key to do that initial session key exchange. Now both sides have the same symmetric key or session key, and they can use that now to start encrypting the rest of the traffic. So this is the reason why one of these parties has to have a certificate so that it can be validated and used to encrypt that session key to do that key exchange. So like I said, DB2, we support this between client and server. More recently, it's been added to encrypt the traffic between HADR primary and standby. It's a slightly different configuration you have to set up than the client server, but it encrypts all of that log stream sent between primary and standby. Remember, your certificates expire when you go to set this up. It's just one thing to watch out for is that they often have short lives that are getting shorter. The industry is moving to shorter and shorter timeframes. So what might have been several years in the past, maybe it's down to a year now, maybe it's down to 90 days that they do expire. And once they expire, it'll prevent new connections from being formed. So once you start down the road of SSL, it's something that you have to keep on top of, is generating new certificates. You can sort of think of it as like, rotating your password, changing your password every 90 days or something, that these expire and have to be set up again. So just watch out for that. A few changes to TLS, just to make everybody aware of that. 11.5.8, we added support just very recently, within the last couple months. This has come out, support for TLS 1.3. Sorry, the latest and greatest version is there. And we have updated OneGet connection to actually show what version is being used and what ciphers have been negotiated. And so this can help you track down which clients might still be at really old levels that don't even support TLS 1.3 or 1.2 or something like that. You can see which clients are using which version, or proof to an auditor, hey, look, all of my connections are using 1.3, that sort of thing. So in 11.5.6, we added hostname validation. So this is a feature where the client actually checks the hostname that it's connecting to is what exists inside the certificate. So not only is the certificate not expired and issued by a trusted provider, that the host names actually match. So previously, before 11.5.6, we were not doing this. It's something that has to be manually configured just because it'll probably break a lot of connections. People weren't aware that they had to create certificates in a certain manner in the past. So it needs to be manually turned on at the client, but I strongly recommend it, that you do so. We also added support for the client specifying the version it wants to use. Previously, it just accepted whatever the server had. You can now actually control and sort of force that you want a certain version from the client. Simplified SSL setup that we had in the past has been extended to the CLP and embedded SQL applications. That's just where you don't create a key store, but instead give us the root CA certificate directly as a file. One other small thing is the subject name indicator is being sent from the C-based clients during the TLS handshake. It's an advanced feature that you sort of only run into if you have like a load balancer in front of DB2 that needs to know, maybe it's load balancing many different databases and it needs to know which one to go to. So if you know you need it, you know what it is. So otherwise I wouldn't worry too much about the SNI. And data at rest. So this is when you are encrypting data, not as it travels over the network, but as it gets written to disk. DB2, sort of two primary methods. One is you look at file system encryption, where it's done at the operating system or with a product such as Guardium Data Encryption, or DB2's native encryption, where we do the encryption ourselves before writing to disk. And that's what we'll take a quick look at here. This is DB2 encrypting your database files, backups, and log files, right? So the places where you have the customer data gets written to will be encrypted, done by DB2. So this is sort of a graphical representation of that. So you have your table space data, your log files getting encrypted, you have your backup down here, but what is not encrypted, for example, is an export, right? A user comes along and does, say, a select star from a table, and then they get back at the client. They can, it's all plain text to them. They could write it somewhere. So that is not encrypted, but the actual backups are. So you'll see this sometimes referred to as transparent data encryption, just because it's a feature that your applications don't really know about. It's built into DB2. It's there now with all offerings free of charge, and it just encrypts data as it gets written to disk, comes back, a user issues a select statement, DB2 says, well, you're authorized, so I'm going to give you back the decrypted or plain text data. We use hardware acceleration, which I'll talk about a bit more in a minute. Yeah, sorry, okay, so this is where I mentioned the transparent applications or transparent data encryption. That it's not really being used as an access control method. So if a user is allowed to see the table, they have select privilege, they will always see plain text data. This is not sending them back encrypted data because they don't have access to it. It's transparent to the applications, and everything is managed behind the scenes when data is read in and out of the buffer pools. We have sophisticated key management that we're going to talk about in just one second. Here we go. So we use what's called a two-tier model for key management, that the data on disk is encrypted with a data encryption key, which resides with the database or with the backup. And that DEK, the data encryption key, is encrypted with a master key. And the master key is stored outside of DB2. So there's a few different options, but it's something outside of the database server that you need access to in order to come in and decrypt any of the data. So it allows you, control of that master key, but it also means its responsibility is up to you and you need to back it up. So it's very important to realize if you're using native encryption, make sure you back up your master key because it's managed outside of the database. We support several different methods of managing that master key. So by default, we include a local key store file, which is just a file on disk at the database server. It's simple, it's free, it's easy to use, comes with DB2 to do that, but it's a little more complicated to manage, right? Especially if you're using HEDR, PureScale, DPF, you now have to copy and synchronize that key store across many servers. There are other products out there that you can use to do centralized key management. So there's two types. One is a hardware security module, or the other is a KMIP server. KMIP is Key Management Interoperability Protocol. That's a tough one. These are sort of like LDAP servers for your keys. So typically in an enterprise, your security team is going to have one of these set up for the enterprise to manage all of the encryption keys across the enterprise. They will be backed up, they will be highly available, and it's a great option for where to store your master keys for DB2 so that they are well taken care of. These are just, again, a couple pictures that I'm going to leave as some homework for everybody that kind of just shows the mechanism of where DB2 is getting the master key from, how it's using that to encrypt and decrypt the data encryption key that is then used to get at the actual encrypted database files and backup files. So just the different types here that we're going to go through. If you're considering encryption, availability is an option that you need to worry about for your key stores. Operations, just how are you going to rotate your keys? How do you actually do the backups? Things to worry about are documented here. And performance. Performance does get degraded by how much is a really big factor, depending on a lot of things as performance does. Just a lot of it gets hidden by the buffer pools because we're encrypting and decrypting in the background. But it may require some tuning of your system because it's really just like slow disks now. So we have, a number of good guidance that you're going to want to follow if you're going to be enabling native encryption, which I strongly suggest you do. So, okay, the whirlwind tour is over, and we've got through all of those features. So I hope everybody has learned something new and can take away something they didn't know before about security in DB2.
Well, that's an awful lot of information in a very short period of time. You call it a primer, and it was absolutely fantastic, Greg. Thank you so much.
Oh, you're welcome.
And what we'll do is ask our final polling question, which we always like to ask on the show, which is, did you learn anything today? And I'm suspecting that people will have a chance to answer that, and we'll do that quickly, and we will share the results. And the answer is 100% of the people learned something, which is not surprising. Excellent. And that's fantastic. So with that, I will take back control to do the final thank yous and remind people of our sponsor and things like that. And so let me bring up my screen here and once again remind people that the founding sponsor of the DB2Night show is DBI Software. We thank them for the use of the hall, so to speak. And I'll cue the music and And we'll call it a weekend and invite everybody to enjoy it. So with that, once again, Greg, thanks so much. You've already sent me your slides, so I'll post those on the replay blog today. And everybody have a great weekend, and we'll see you next week for Brian Lowby on temporary tables. All the best. Bye-bye.
Thanks, everyone. Bye-bye.
Thank you. Great. Bye-bye.